Okay, so now what we're going to do today is we're going to compare the graphs that we've been working with this whole time. Okay, so we're looking at key features. We're going to compare them to each other. This one is higher than this one, or this one decreased when that one increased. We're just going to be looking at the differences between what's happening. Okay, the first one is a tennis problem. Hawkeye is a computer system used in tennis to track the path of a ball. It's used as an officiating aid to locate the landing spot of a tennis ball when players challenge a call. Use the description and graph of a player's forehand and backhand shots to compare the paths of the two shots. If y is the vertical height and x is the distance, okay? It's like how far it went out versus how high it got in the air, okay? Do we know the difference between forehand and backhand, by the way?
Yes.
I don't know if you're tennis people. So forehand is when your forearm is facing forward, right? When you hit the ball with your tennis hand. Backhand is when you swing and like the back side of your hand, that side of the racket hits the ball, okay? So it's comparing hitting it forehand and hitting it backhand and just the traveling of it, okay? The graph shows me the backhand, okay? Forehand, they gave me a description, but we can use that description. I like to graph things like on the same because y'all know I like to see things. So backhand's already there. I'm going to use what they give me about the forehand, and I'm going to sketch me a graph on the same graph, okay? So the ball leaves the player's racket at a height of 2.8 feet. Okay. So 2.8, I'm going to put it right about here-ish, close to that line, but not quite. It travels 29 feet when it reaches a height of about 10. So it's going to have an X of 29 and a Y of 10 is like a maximum height. So 29 and 10 is going to be about right here. And then it hits the ground 58 feet from where it started. So here is 60. 58 feet would be a little bit before. Okay, too loud.
You can hear it?
Yep. All right, so it goes up here, and then it goes down. So my purple here, and I know you don't have different colors, so what's already there, you can label with like a B for backhand. And then the purple that I'm putting on here, I'll label as F for forehand. Okay. Excuse me. It should be before the 60. Thank you. Sorry. You are right. Yep, it should be before the 60. There we go. There we go. And then here's my backhand. All right, thank you. So if you know tennis, backhand, they usually go higher just because of the angle of your wrist. So that usually is like your ankle up. It's going to make it go up higher. So we have graphs. We have pictures. They were also nice enough to give us a detailed table of exactly where things are. Okay. So the first thing we're going to compare to each other are the x-intercepts. Okay. So looking at my x-intercepts, the forehand has an x-intercept of 58. The backhand has a x-intercept of 70. So what does that mean about my tennis ball? Is x-intercept how far it went or how high it went? How far it went. Thank you. Okay. So which ball went farther? The backhand went farther. By how much?
By like 15 feet. Like 20 feet. I don't know.
Between 58 and 70. It tells you. You don't have to guess. Almost.
29.
58 to 70 has a difference of what? 12. 12. There we go. Huh?
Where's the 12 at?
The difference between 58 and 70 is 12.
Yeah, but you said it's right up there. I looked up there. I had seen 12.
The difference between 58 and 70. Okay? The backhand went 70 feet away. Okay? Forehand went 58 feet away. So the backhand went 12 feet farther than hitting it for the forehand. Does that make sense? That's where the 12 is coming from. So that's what we're gonna write for our comparison. Okay, so we said backhand. I'm just gonna use B and F instead of writing out backhand, forehand every time. Is that okay?
Yeah.
So I'm gonna say B backhand traveled 12 feet farther away than our forehand. So I'm using B and F for backhand, forehand. Okay, how about our y-intercepts? Yeah, our F started off higher, right? I don't know if y'all watch tennis. Sometimes they throw the ball, right? I think we always throw the ball. They throw the ball, then they hit the ball, right? So when they hit it with their forehand, wouldn't that make sense if I hit the ball with my forehand versus trying to... That makes sense, right? Or even if it's coming at me, even if I'm not serving, if the ball's coming at me, I can reach higher from a forehand, right? Backhand, you tend to be kind of lower. So again, when your math makes sense, that's nice. So this makes sense that my forehand had a y-intercept that was higher. So my forehand starts, and it's 2.8 versus 2.5. So it starts 0.3, I should say feet, 0.3 feet higher than our backhand. All right, our extremas. So looking at my graph, which one went higher in the air?
On the F.
The forehand definitely went higher, okay? But we can't just say, or the forehand went higher. We need to be specific. How much higher, okay? The forehand got to 10 feet when the backhand got to 7 feet. So what can I say?
13.
My forehand reached a maximum height that was 3 feet higher than the backhand. Reached a max height that is 3 feet higher than the backhand. I know my handwriting's not awesome. F, so our forehand reached a maximum height that is 3 feet higher than my backhand. Tracy's supposed to be paying attention. All right. How about increasing and decreasing? Do they both increase and then decrease? Hey. Me? All right, so they're both increasing and decreasing, right? Okay, but what else could I say about the increase and decrease? So let's see, they told me down here. So forehand increases to a height of 10 from 0 to 29, and then decreases from 29 to 58. All right, and then backhand was increasing, got to a height of 7 from 0 to 35, and then decreased from 35 to 70. So we could say that the backhand increased for a longer amount of time. Does that make sense? Because it looks like my forehand took 29 seconds before it turned. My backhand took 35 seconds before it turned. Would that make sense? Mm-hmm. Okay. Yes? Okay. And I think the same coming down. It's also going to take longer for it to decrease. So let's say backhand takes, we can't just say takes longer. How much longer? No, don't guess. So 0 to 29 versus 0 to 35. 6 seconds longer, right? The forehand turned after 29 seconds. The backhand turned after 35 seconds. Okay? So 6 seconds. So our backhand takes 6 seconds. More, I'm going to say longer. 6 seconds longer to increase and decrease. Makes sense, right? Look at my blue graph up here. See how it's wider? So that shows it took longer to reach those spots. Okay, so B takes 6 seconds longer to increase and decrease. All right, let's finish off with some blue. Last one is domain and range. Okay, so that's not in my table, but it kind of is. Remember, my domain are my X values, and my range are my Y values. So domain, if I look at my forehand, it went from 0 to 58 feet, right? And my backhand went from 0 to 70 feet. So which one had the larger domain?
Backhand.
The backhand, okay? The backhand had a larger range of X values, right? So for my my domain, backhand took a longer amount of time because not time. What is X? Distance in feet. So my backhand traveled, come on, pen. I changed its batteries this morning. There we go. Traveled the farthest. And then when it comes to my range, that's our Y values. Which one could we say went the highest?
Oh, no, forehand.
Yes, our forehand. Yep. And our forehand traveled the tallest. Okay, so domain was my X's. So my backhand traveled the farthest away. But my range is my Y values. My forehand traveled higher up in the air.
Why did you say travel the highest and the tallest?
Same thing. Yeah, if you put highest, you're not wrong. If you said travel the highest, that's okay. All right, so does that make sense what we're doing today? They're really doing the work for us. We're just comparing what's happening. Okay? Let's do another one. Here we go. We have rural, can never say that word, and we have urban population. Okay? So about, what is that? 745 billion. Million. 440,000 people lived in the rural regions of China in 2005. Since then, the rural population of China has been steadily decreasing to 618,660,000 in 2014. Right? And then we have a graph of our urban population. Okay, so just like last time, I'm going to graph it on top so I can visually see both. Okay, so this is our urban. I'll give that a U. Let's make rural. What do you want to make it? Green? Okay, so we started off at 745, so about right here. Do you agree?
Yeah.
It's a good spot to start. And it ended 2014 at 618. Okay, I don't see a 14 down there. What are these? These are years since 2005. So 1 is really 2006, right? 2 is 2007. Does that make sense? 2008, 2009, 2010. Yeah? 11, 12, 13, 14. So 9 years. Does that make sense? Represents the year 2014. It's been 9 years since 2005. Okay, so 9, and then what did it say? 618? So about right here. What makes no sense? The X's? The X's? Okay, see how it's labeled? Years since 2005? So 1 means 1 year since 2005, which means it's 2006, right? 5 years since 2005 would represent the year 2010. Okay, it specifically says in my description 2014, right? So 9 years after 2005 would give me 2014. So that's why we're looking at 9. And it told me at that point it was about 618 million. So I have a beginning, I have an end. You only need 2 points to make a line, right? So let's connect these. Like this. All right. So, yeah, roll. All right, which statements are true about the populations of China? Okay, so we're going to select all that apply. So there might be more than one answer. Do you have a question? Okay. All right, so let's read the first one. There were fewer people living in urban areas of China in 2005. Okay, well let's test it. Okay, hold on. In 2005, so that's going to be the year what? On my x-axis, is it going to be 0? Which one? 0, right? It's representing years since 2005. So if we're looking at 2005, we're looking at the beginning. So we're looking at this point and this point. Which one is smaller? The urban is smaller. So therefore, this is true. Okay, so far that is true. Let's see what else do they have going on. The rural population of China has been increasing while the urban population has been decreasing. False. They had it flip-flops, right? So that one is not true. Cross that out. All right, C. The number of years since 2005 increases. Oh, as the numbers, okay, since 2005 increase, the rural population of China decreases while urban increases. Do we agree? Rural is going down, urban is going up. Yes. So we like C. C is good. All right, Chase. What? I told you need to focus. Okay, but I don't want you playing games on your phone either. Got it? That's the issue. Okay. The rural and urban populations of China are positive for years after 2005 and negative for years before 2005.
Close.
Can you have a negative population?
No.
No, that doesn't make sense. No, that's not happening. All right, both the rural and urban populations of China have been steadily decreasing. No, they have not. One of them was, but what? Urban was increasing. Both rural and urban populations can be modeled by linear functions. Yes, good. Okay, so listen, I know there's lots of words, and I know that freaks you out. You gotta take it one step at a time. Okay? Read one, see if it's true or not. Okay? Totally make them separate problems. All right. So we have A, C, and F. Okay. Here we go. We have 2 more. They just take up a lot of room on the paper, but we have 2 more problems. Okay, we have cars. The description and graph to compare the fuel economy of 2 cars, where Y is the miles per gallon and X is the speed in miles per hour. So here we go. We have car A and we have car B. Okay, this is going to be fun. So car A, the fuel efficiency increases for speeds up to 25 when it reaches a relative maximum of 53. The fuel efficiency then decreases. Okay, I'm going to take this sentence by sentence, because this is going to get real crazy real quick. Do you agree? Yeah? Okay, so let's take it sentence by sentence. So my first sentence says, it increases for speeds up to 25 miles per hour when it reaches a relative maximum of 53 miles per hour. Okay. So my speed is my X, and my efficiency is going to be my Y. So it's going to increase until it reaches the point 2553. Is anyone confused on where I just got that from?
No.
Okay. It says increases, so we know we're going up. Okay. 25 miles per hour. Look at my graph. That's down here. Those are my X values. So we're going to increase to up to this point. And then efficiency, as it tells me over here, is my Y's. And that's going to be about 53. So we are going to increase until we reach that point. Like that. Okay. All right, my next sentence. Here we go. I'm going to highlight them as I do them. Our next sentence. The fuel efficiency then decreases for speeds between 25 and 41 when it gets down to 37. Okay, so now we are going to decrease until we reach what? 41? 25, 41. And it's going to be 37 miles per gallon. So about right here. Does that make sense? So I'm extending across until I hit the 41 miles per hour. And my efficiency dropped down to 37. So we're going to go down to hit there. So 25 is where I just came from. I just came from 25. So it's saying, remember it says it increased up to 25. And now from 25, it's going to decrease until it hits 41. All right. Next sentence. Above 41 miles per hour. So as we keep going, y'all stay with me. Efficiency increases again until it reaches 48 miles per gallon at 60 miles per hour. Okay, so we're going to increase again until we reach the speed of 60 miles per hour. So we're going to stop at 60. And it went up to a height of 48. Like that. All right. Here we go. Finally, the fuel efficiency rapidly decreases, so we're going down now, for speeds greater than 60 miles an hour until leveling off at 17 miles per gallon. Okay, so it's going to drastically decrease until it levels off at 17. So 17 is about here-ish. So we're going to drop down real quick and then level off like that. It said 17. So it didn't really give me it just said greater than 60. Yeah, it said rapidly decreasing, so I just dropped it straight down real quick. Yep. So we have car A and we have car B. Okay, here we go. Let's compare these guys. Select all that apply. So we're going to check them off or X them out as we read them. As speed increases, the car A levels off at a greater fuel efficiency than car B. So which one levels off the highest?
B.
B is the highest, right? Is that what it says? It says car A levels off greater than B. So that's wrong. Okay? Because technically, B leveled off higher than A did. See how B is above it on the very end? Okay. Neither car reaches fuel efficiency below 0 miles per gallon. That is true. Yeah, we like that one. Okay. Car B has more relative maximum fuel efficiencies than car A. Let's see. Car B has more relative maximums. Okay, so it's saying that B has more peaks than A does. So let's figure that out. How many peaks does B have? 1, 2, 3 is what B has. And A has 2 peaks. Okay, so which one has more? B has more. So is this true? Yes. Yep. Y'all see how we figured that one out? We counted the bumps. Okay? B had 3 bumps, A only had 2. So B has more. All right. Both cars increase in fuel efficiency for speeds between 0 and 13 miles per hour. So are they both increasing between 0 and 13?
Yeah.
I would say yeah. They're both going up. Car A would continue to go up, right? But I would say between those exact X values, they are both increasing. So this is good. Car A has the least relative minimum fuel efficiency. So who has the lowest dip? I think B might have the lowest dip. So I'm looking like right here versus right here. It's pretty cool. Well, at the end is level off. The end is leveling off. To be a minimum, you have to go down and then go back up again. Does that make sense? That's what makes it a minimum. So I would agree it's B. Is that what they say? Nope. Okay. So I'm gonna cross that off. I do not agree with that. Are we good with that one? Do you get what I was saying? To be a minimum, you have to go down and then come back up again. That's how you get a minimum value. So looking at the graph, it looks like car B had the lowest dip between B and A. All right. Car A has the greatest maximum fuel efficiency. All right. So who gets to the highest? Who gets the highest? I think that's going to be the highest. Yeah. That's definitely B. So I would definitely say that that's closer to 60. And it told us, where was it? Our maximum height was about 53. That looked closer to 60 than 53. So I would agree that this is true. Is that what I said? No, I lied. I lied. B. Oh, gosh. I'm confusing myself. Okay. So that should say B. That should say B. All right. Both cars get 0 miles per gallon when they are traveling at 0 miles per hour. Do they both start at 0, 0? Yeah. That's showing where they start. Makes sense, right? If we're not traveling anywhere, are we using any fuel? No. So that makes sense. Okay. Here we go. One more. All right, use the description and graph to compare the number of employees working at 2 department stores over a 12-hour period, where Y is the number of employees and X is the time in hours since the stores open. All right? At the start of the day, the store had 30 employees working. After being open for 6 hours, 50 employees were working. The number of employees then decreased until the store closed 15 hours after opening, and there were no employees working. Okay, so let's put this on my graph. Y'all know I gotta see it. So my graph shows store B. I want to put store A on the same graph. Okay? At the start of the day, the store had 30 employees working. So at the start, I should have a y-intercept of 30. We are starting at 30. Start 30. So we're going to start right there. Okay. After being open for 6 hours, so 6 hours since opening, right? We're looking right here. Now we have 50 employees working. So 60 and 50, I'm going to put a point on that spot. So 60 and 50 was our next point. The number of employees then decreased until the store closed 15 hours after opening and there were no employees working. So 15 hours, no employees. 15 hours, no employees. That's going to show me right there. We closed and no one's working anymore. So now we can draw our curve. Whoop, come on. There we go. Okay. So now what we're going to do in this paragraph is we're going to circle, highlight like what the right answer should be. Yeah. So we're circling the right answer. At the beginning of the day, there were more employees working at store
No B.
Remember, my green is A. Helps to label things, right? My green is A, my blue is B. Okay, so which one started off with more employees during the, we start off, store A had more employees to start off with because my y-intercept was higher. They had about 30 employees. Looks like store B had about 20 employees when they started. All right, the maximum number of employees working at store B during the day, was it more than, less than, or equal to the maximum number of employees working at store A? We're comparing B to A, so blue to green. Is blue higher than green? Is blue lower than green? Or is blue the same as green at the maximum point? Blue is higher, so we're going to say more than. All right. The maximum number of employees working at store A, started over. Last sentence, store B closed earlier, the same, or later than store A. So B is blue. Did blue close before, the same, or after the green? Where do I look? Where do I even look to figure out where they're closing? We're looking at the bottom. Yeah, right here. So we're looking at my blue. My blue. They hit at the same point?
No, they didn't.
Blue closed earlier. See how blue has a x-intercept at about, almost 14-ish, 13 and a half maybe? And green has an x-intercept of about 15. So blue closed earlier. So store B closed earlier than store A. All right, good job.